Now in this video we'll see one example for FLSM using a B class. Like if we just get back to the basic examples what we have seen in the previous classes, we have seen some C class examples with a requirement of 30 hosts and a requirement of 50 hosts, where we are dividing one C class network into multiple small networks based on FLSM. Now probably in this section we'll go with FLSM example, but the requirement is, let's say, 1000 hosts. Now B class by default supports 65,536 addresses, because in B class there are two network portions and two host portions. So which means the host bits will be 16 and 2 to the power of 16 is 65,536. Now the default size for any B class network is 65,536, where I don't want such a big size and I want to divide this network into small networks, so that each and every network will get a requirement of 1000 hosts. Now how to do that? So we need to go with the same step-by-step calculation, like we need to go with 2 to the power of h minus 2, and my requirement is 1000. Now if you go with 2 to the power of h minus 2, 1000 is your requirement, so the possible size will be 2 to the power of 10, 1024. So even though my requirement is 1000, we cannot get exactly 1000. We need to go with 2 to the power of 10, that is 1024, and in that again we cannot use two addresses, one for network ID, the first IP of the range, and one for broadcast ID. So total valid addresses I can use up to 1022. Means if my requirement goes more than 1000, I can go maximum of 1022 addresses in the future. Now as we are using B class, and B class supports by default there are two network portions and two host portions, and which means there are total host bits are by default 16, but out of 16 we just need only 10. So I'm going to use only 10 host bits, and the remaining 6 we are going to convert them into network. And so the converted network bits will be from total 16. Total there are 16 bits. From 16 we are subtracting 10 and we are converting 6, and here you can see these conversions here. Now total bits becomes 22. By default there are 16 plus 6 more added, so the tally of 16 will change to 22 and 10. So now there are 22 network bits and 10 host bits, and that is what we call a slash value again. And then the subnet mask is 255. If you add 6 bits, 128 plus 64 plus 32 plus 16 plus 8 plus 4, it's going to be 255.2.0. And if you want to find how many subnets we get, so 2 to the power of converted network bits, now there are 6 converted network bits, 2 to the power of 6, 64 subnets we get. Now up to here the entire calculation is exactly the same what we did for the previous C class. Now the only difference is the number of bits. Now in case of C class we had to take 3 network portions and 1 host portion, but whereas in the B class we are taking 2 network and 2 host portions. Now the next thing is we need to write the range. Now writing the range is something difficult here, because the range always written based on the 2 to the power of h value. Right now after subnetting we got 10 host bits, so the size of the network is 1024. So 1024 is our size of each network. So if I go and write 0.x, like 0.1, 0.2, 0.3, I'm going to write the complete 0.x. I get only 256 addresses, and 0.255 will end, and there is no address called 0.256. Inside the continuation will be 1.0. Now 1.0 is a continuation, so I'm writing 0.x complete from 0 to 255, and we are writing 1.x to 1.255 complete 1.x, and we're writing complete 2.x complete 3.x. So if you write complete 0.x block, you get only 256 addresses. So we are writing 1.x as well, we get 256 addresses, and the total becomes how much? 512. And we are writing 2.x, it's going to be 768, 256 plus 256 plus 256, and then I'm writing complete 3.x as well, and we are getting 256 addresses. Total becomes 1024. Now in general, if you try to figure out the group of 1024 addresses, it's going to start from 0.0 and it's going to end on 3.255. So this is the way we generally go on write that many addresses in general. But when it comes to submitting examples or when it comes to examinations, probably if you go with this method, it's going to be somewhat lengthier. Now instead I use a simple formula, 2 to the power of h divided by 256. Now each block, I refer this as a block, each block will have 256 addresses. So how many blocks I require for 1024 addresses? So it's going to be 256, just make a round figure, 250 and 1000, I get 4 blocks. So which means if you want to have 1024 addresses, we need 4 blocks of addresses. So 4 blocks will be, if I'm starting from 0 dot, it will be 0.x, 1.x, 2.x and 3.x. So x represents all the addresses from 0 to 255. So we need 4 blocks of addresses. Now that's something what I generally use to refer. So if you want all addresses, now the range will be multiples of 4 in the third portion. 0 plus 4 plus 4 plus 4 plus 4, like that. Or in general, normally if you are calculating, we need to take like this: 1 block, 2 block, 3 blocks and 4 blocks. So each block is having 256 addresses, multiplied by 4, it's going to be 1024 addresses. Now in this example, what you have learned is how to write the range for bigger numbers. So any number which is 256 or more than 256, we need to take in terms of blocks, and we increment on this portion because our network size is much bigger than 256.